right, so we're going to start some matrix basic operations. Nothing too crazy here. However, we're going to do determinants also, and they're very important. Okay, you're going to need them next week. We're aiming for a test at the end of next week, Friday. All right, Monday, Tuesday, new material, Wednesday, Thursday, review, and Friday, test. That's the goal. All right, so let's start with some basic matrix operations. This is, like I said, not going to be anything too crazy. We're going to try subtracting because the adding and subtracting is really similar. We're going to try multiplying by a scalar, and we're going to do two examples to do that because you've had these before. So, you all right? All right. So let's say that you have this matrix. Give me some numbers.
6,
12, 11. Minus 4, 6, 3. Why not? All right. Now, in order to add and subtract matrices, you're going to basically do what it says to the numbers that are in the same positions, and you're going to put the result in that same type of position. So what that means is, in order for everything to have a pair, you have to have the same size matrices to add and subtract. Okay, I didn't put that in your description over there. Well, yeah, I did. Need the same size matrix in order to do this. So are these the same size? Mm-hmm.
Yes.
Yeah. So we're going to go ahead and subtract them because that's what it says to do. If it said add, we would add. Yes, sir. Oh, hang on just a second. All right, so I'm going to, if it's okay with you, since you've had this a couple times before, I'm going to go ahead and not show what I would call the work matrix for this one. I'm just going to put the result over here. All right, we're going to talk about how to get it. So 3 minus 4 gives me what? Negative 1. All right. 6 minus 9 gives me negative 3. 12 minus, careful, negative 6 gives me
18.
Very good. Thank you. You have to change it to plus because you have minus negative. And then 11 minus negative 3 gives me positive 14. And that would be your solution. Nothing too crazy. Like I said, here we go. All right. Ready for another one? Yay, nay.
Yeah.
We okay, gentlemen? Everything all right?
Yeah.
So let's say that I have matrix A is, let's go with 3 by 3 this time. No, let's go with 2 by 2 because it'll be easier, faster. Give me some numbers. 12,
3,
6,
10, 1, negative 11.
Actually, I'm going to go this way. Negative 11. Okay. And let's say that I have matrix B is equal to, give me 6 more numbers.
649. 600.
No.
No. 4.
5, that's easy.
1.
Oh, come on.
No.
1,
doing?
0.
Negative 72.
There we go. Huh?
Negative 72.
You all better have calculators out. because this is
7.
where I was going with my head.
112.
No, 18.
I don't like this.
Okay, so let's say that you want to take B minus 3A. Okay? So now we're going to multiply by a scalar at the same time that we're subtracting. All right? Now this time I might go ahead and take A times 3 and change all those values and write down what all those values are so that I don't have to do too much at once. Okay, but it's kind of up to you. Let's go ahead and do that for right now since this is the first time you've done it in at least a year. 649, 532, 1, 0, negative 72, 18. There we go. That's matrix B. Then I'm supposed to subtract 3 times matrix A. So if I multiply matrix A by 3, I get, you multiply by a scalar by multiplying all of the elements by that scalar. If you're dividing, you do the same thing. You divide all of the elements by that scalar. Okay? Like, same type of skill. All right, so 3 times matrix A is going to give me, let's see. Yep, 36, 9, good, not 6. Okay, 18. Now 6, 30, and negative 33. All right. Now, we need to subtract those. So 649 minus 36. In order to subtract matrices, remember you're going to subtract the things in the same positions. These are the same size, so we can do that. If it ever comes out that you can't do something that they're asking you to do, just write not possible. Okay? 649 minus 36 gives me 613. 532 minus 9 gives me 523. 1 minus 18, yeah, and 0 minus 6, you got to be really careful not to drop negatives with subtraction. Negative 72 minus 30.
-102.
Good job. And 18 minus 30 minus negative 33.
51.
Yep, you got to add because it's minus negative. There's your result. Do you feel like you need more practice with adding, subtracting, and multiplying by a scalar?
No.
We good? Okay. By the way, notice that matrix names are with capital letters, usually bold letters, but it's really difficult to illustrate that on paper and with markers and so forth. But capital letters, unlike vectors that usually get lowercase bold letters. Okay, so matrices usually get capital letters for their names, and they can give you an expression that involves those letters. You had no problem with it when we worked through it up there. It's no more difficult than that. All right? Okay. To multiply matrices, now we're going to do some matrix multiplication. You have to have, okay, so to multiply matrices, you're going to multiply across the first matrix and down the second matrix, whether you remember that or not from Algebra 2. So at the same time you're going across the first one, you're going down the second one. Okay, and you're going to multiply things that are like elements across the first one as you go down the second. So you have to have the same number of elements across the first one as you do down the second one. They all have to have a buddy. Okay, and you're going to add the products. This sounds more difficult than it is. Watch, here we go. All right. So to multiply matrices, it is oftentimes not possible. So it has to be a very, I shouldn't say oftentimes, it has to be a very specific case to be possible to multiply matrices. You have to have the same number of elements across as you do down in the second one, because you're going to be multiplying in that fashion. All right. Okay. So here we go. We're going to multiply these matrices. Ready? All right, this is where my different colors are going to come in. Because I'm going to do a different color. You're going to put the result of your products and sum in the, like if I multiply first row times first column, I'm going to put that sum in my first row, first column position of my new matrix. So it's going to go in the upper right corner, or upper left corner rather. All right, so again, I think I'm going to, no, we better show some work on this one. A little bit of work, not all of it maybe, but here we go. Okay, so let's say first row times the first column. Here we go. So first row times the first column. What you're going to do is you're going to take -2 times 4, which gives you -8. And you're going to add that to 1 times 3. All right. So you're going to go across the first one as you're going down the second one. Does that make sense? It'll take a little bit of getting used to maybe, but I think you'll catch on quickly. All right, and -8 plus 3 does give you -5. Okay, different color. Orange. Let's take first row times the second column in the next matrix. So negative 2, 1 times negative 6, 2. Ready? We take negative 2 times negative 6, and we add 1 times 2. So negative 2 times negative 6 gives me 12, and 1 times 2 gives me 2. And I'm going to add. Okay, so that gives me 14 as a result.
Second row, first column.
Now second row gets a turn. Okay, so second row, 0, 3. I need to multiply that by the first column. So 4, 3. So 0 times 4 gives me plus 3 times 3 gives me 9. All right, second row times second column. Here we go. Second row, second column. Okay, so 0 times negative 6 gives me 0, and 3 times 2 gives me 6, and I add those. Oh, I forgot to write down my, here we go. So my last row in my new matrix, my product matrix, is 9, 6. So I have negative 5, 14, 9, 6. What do you think? Does that make sense? We're going to do another multiplying one. Don't worry. The technique doesn't change, but you have to be really careful whether you can even do the multiplication or not. Not just, you know, how to do it, but can you even, is it even possible to do that? Okay? All right. Notice that the number of elements across the first matrix has to be the same as the number of elements down the second matrix. They don't have to be square, but the dimensions have to be the same across the first one as they are down the second one. All right. May I erase this? Okay. Oh dear. All right. Let's see. Ready for some more numbers? Small ones. Under 10, like 10 or less.
3,
1/2. I'm just kidding. I'm just kidding. Don't do that.
7,
8.
6,
0, I like 0. Let's give
4.
another 3, let's go negative 3. It's a lucky number. Okay, that one times the second matrix, how many elements does it have to have?
9.
It has to have 9? Well, it has to have
3 rows, 3 columns.
3, doesn't have to have 3 by 3, but it has to have at least 3 going down because you have 3 going across the first one. Does that make sense?
Yeah.
Okay, so let's try this. Let's see. 0, negative 5.
There's still 1 column.
Yeah, we could do 1. We'll get a little more practice on that. So, negative 1, 2.
That's right.
And then negative 2, why not? And 10. Okay. So we're going to show our work in our work matrix, like I said. All right. And we'll put our answer matrix down here. All right. So let's start. How do we start multiplying matrices?
First row, first column.
First row times the first column. Okay, so I'm going to take this row times this column. So I get what numbers added together?
0,
0,
3.
negative 3.
Oh, there's a negative 3.
You're good.
Negative 3 and positive 4.
Okay, so 0, negative 3. I'm adding, but I'll put a plus there. Okay, and positive 4. Okay, that's the first row, first column position. Right? That's going to give me, by the way, 1 for the first row, first column result. Okay. Moving right along. You still need, you could
First
do,
row, second column.
you could go diagonally, but you might as well keep with the first row, but switch to the second column. Or if you switch to the second row, go to the first column so that you don't lose track of what you're doing where. Try to be very methodical about this so that you don't make mistakes putting wrong numbers places. Okay, so 1, 3, -2, take that one times -5, 2, 10. Okay,
Negative 5
yep, -5
plus 5
plus
or 6.
6. See why I'm writing down the work matrix so we can find mistakes if we make them, right?
Yeah.
All right.
Plus -20.
Plus -20. Okay, and -5 plus 6 gives me 1, minus 20 gives me -19. All right. Now I need to let second row take a turn. Okay, so second row times first column. All right, so 5 times 0 plus -7 times -1 plus 8 times -2. So 0 plus,
7
yep,
minus 16.
okay, plus -16 or minus 16. I don't care if you write it as minus, obviously, just up on the board I'm putting plus because it's going to get confused. And 7 and -16 gives me -9. All right,
Second row, second column.
yep, second row, second column. Second row, second column. All right,
They said they wish they had color.
I have colored pencils if you ever wanted. Okay, 5 times -5, -25, plus, yeah,
Plus 80.
plus 80. That looks like a fun one. -25 plus -14 plus 80 gives me 41.
41, yeah.
the 41.
Yeah.
All right. 6, 0, -3 needs a turn. So here we go. That one times this one.
6.
Really? Oh, answer of 6.
Yeah.
That I believe. So
Well,
6
6
times
times
0 is
0.
0, plus 0 times -1 is 0, but -3 times -2,
Positive 6.
all right, does give me plus 6.
Good.
All right. All right. 6, 0, -3 times -5, 2, 10. All right. So I get -30
Plus 0.
plus 0
Minus 30.
plus -30 or minus 30.
-6.
So -60. So try not to use that much. Okay. What do you think? You got it? See some heads shaking. Are we all right? Okay, now, a determinant. Now, to take the determinant, by the way, I'm going to point this out first. The determinant will always come out to be a number. One number, like it's a constant, okay? You're going to be multiplying and subtracting and things like that, but it's going to be all one string of subtraction and addition and multiplication. You're going to add them and subtract them and things, so it's going to turn out to be a number, okay? So here we go. May I erase this? Yes?
Yes.
What? 44, 35. What?
44 minutes and 35 seconds left. Keep counting down.
You always do.
All right.
I'd just like to know where I'm at.
If you don't have a clock.
I know it's because I need to bring in a battery. All right. So, by the way, I know, but you can only take the
You need to show yourself not to use that one.
no, this is good. But I'll use the light for the one. All right, so you can take the determinant only of square matrices. So they have to have the same number of rows as they do columns. Okay, by the way, if anybody has trouble keeping straight, what's a row, what's a column? No, yes?
Column is down, row.
Yep.
No, you're wrong. It's the opposite.
So it's like columns on the White House or whatever, and row, yeah. Horizontal, okay, here we go. So to take the determinant, remember you can only do that of a square matrix. We're going to take the determinant of a 2 by 2 first, okay? And the technique is as follows. You multiply diagonally, and then you subtract the product going the other direction, and the order does matter, okay? Or direction does matter, I should say. So you're going to multiply this direction first, and you're going to subtract the products going in this direction, okay? Now for a 2 by 2 matrix, you're only going to have one product going this way and one product going this way, okay? So I'm giving you a formula here. It's like AD minus BC, and one way to symbolize taking the determinant is with DET in front of the matrix. That's probably how you'll find it on a calculator, okay, or on a computer. In writing in the book, or when you're writing on your homework, it's a shorter way if you want to just put straight up and down single bars. Okay, change those brackets for your grouping of your matrix into just straight bars, and that means take the determinant. All right, so it's not just a matrix anymore. Now it tells you to do something. So if I say evaluate and give you a problem that has the straight bars and numbers inside, that means find the determinant. All right. The directions do not have to say take the determinant. Got it?
Got it.
All right. So we're going to do a 2 by 2 first. Let's see. -1, 3, 0, 5. Let's take the determinant of that. Okay, you ready? So I'm going to ask you this. Which family of colors looks positive to you, and which family looks negative? If you had one to illustrate negative numbers,
They're all positive.
That one's negative.
this
That
one's
one's
negative,
positive.
this one's positive.
No, it's the other way around.
We'll go with it. Hey, in accounting, the greens would be positive and the reds would be negative. So that makes some sense.
Yeah.
So we'll go ahead, these are positive, all right? The greens and blues are positive and the pinks are negative. Pinks and purples are negative. Okay, so here we go.
That's clever.
Oh boy, I'm wearing a green positive shirt. Okay, we're gonna take -1 times 5. Watch, -1 times 5. Yes, that gives me -5. That's not my answer though. That's not done, is my point. Okay, and then we're going to subtract 0 times 3 minus 0 times 3. Now you're subtracting again, you're going to have to be really careful not to drop negatives. Okay, so minus 0 times 3, what's 0 times 3?
0.
So -5 minus 0, what's my determinant value? -5. So that matrix determinant is -5. Okay? 2 by 2s are fairly quick. The larger square matrices can take a little bit longer. I have written on the board the spaghetti method, and you might be going, that doesn't make any sense. It shouldn't until you learn what it is, okay? That's, of course, what I was taught that it's called, and it kind of makes some sense, but I'm going to show it to you after we actually do the problem, all right? So here we go. Ready?
Ready.
Are we gonna do any big ones like 13 by 13?
No.
All right.
If you did, you would use a calculator or a computer to do it. We're not going to do that by hand. You can, it's not much more difficult, but it's time consuming, there's not much point.
Whatever. What's that? Not, maybe not 13 by 13, but like 9 by 9.
All right. Here we go. Let's do a 3 by 3, shall we?
Wait, is it a straight line?
Oh yeah, let's do it that way instead. I could put DET in front of it if I wanted, but let's do straight lines. Faster. I'm all about being faster. Okay, Let's go -3, 1, 0. Why not? Zeros are always fun. 2, -2, -1, 4, 3, 6. Close. All right. So, ready to take the determinant? You're still going to multiply on the diagonals, but the thing is that you have to have the same number of elements being multiplied as you do in your rows and columns. So we need to be multiplying 3 numbers all the time, and everybody needs a turn in this matrix, so we can't run out of elements is the thing, on diagonals. Yeah, what's your thought?
Can we take like the opposite or something and put it outside or something?
No, that's inverses, I think, is what you're thinking of. I could be wrong.
I was
Could be,
thinking-
we're gonna be doing some strange stuff next week called cofactors and minor matrices next week. Okay, those all have to do with or will be involved with determinants. They're all gonna have a party on Tuesday, okay? But that's not what we're doing today. Okay, hey, you do not want to run out of numbers. So the -3, -2, 6, those are fine. There's 3 numbers in that diagonal. But this 1, -1, they need a third person, okay, or a third number to be involved. So what you do is you start recopying this matrix. You duplicate it, and you just keep duplicating it as long as you need to until you run out of numbers in your original matrix. Not indefinite. Okay, so for this one, we're going to need to take, let's see, positive numbers. Here we go. We're going to need to take -3 times -2 times 6. And we're going to need to take 1, -1, and somebody down there. So we're going to need a number down there. And we're going to need to take 0 and 2 more numbers. Okay, so we need to recopy. You can recopy the whole thing if you want, but we need at least the first 2 columns over here. So you recopy it in the same order, you like duplicate it. All right, so here I go duplicating it. So you're going to go -3, 2, 4, and 1, -2, 3. Okay, and you can recopy the whole thing if it makes you feel better. It's not going to be wrong, but don't keep multiplying if you're out of your original matrix. All right, see how the 0 is the last one? Okay, so here we go. We're going to take, now that we have our entire matrix that we need written down, here we go. All right, -3 times -2 times +6. +6 times 6 gives me 36. Very good. Okay, you're going to add the ones going in this direction, like I said a minute ago. And subtract the ones going in the other direction. All right? So 36, what do you get when you take 1 times -1 times 4? You need to add, and maybe it would help you to write down the plus sign before you actually figure out the product. That's a hint that I can say I've actually put to the test. All right? That way I don't drop negatives and get confused. 1 times -1 times 4 gives me -4. That's correct. Okay? And then last diagonal, in the positive direction, I get 0 times 2 times 3, which is, so plus 0. Okay, now you have 2 options, and we're going to subtract. But you have 2 options. You could add the products going the other direction and then together first, and then subtract that large quantity. I find it easier to subtract each individual diagonal product. So that's what we're going to do right now. If you want to add them and subtract the total of the diagonals going the other direction, that'll work as well. It's like distributing the negative. Okay? So we're going to go in the other direction. Ready? 4 times -2 times 0. I need to subtract that quantity. That gives me 0. Okay? Then I need to subtract, I told you, writing the sign down before you write the product, sometimes before you even figure out the product, sometimes helps. Subtract 3 times -1 times -3. So -3 times -3 gives me +9. Okay? And then I need to subtract subtract 6 times 2 times 1, so 12. Okay? And then you just evaluate. So you get 32 minus 9, 23, minus 12,
11.
That makes sense? Did we do that right?
Yep.
Hey, yesterday, second period, somebody said, why didn't the 2 get a turn? And the answer is the 2 did get a turn, it got it over here. Okay, and same thing with that negative 2 got a turn right here. Okay, some of them get to be used twice. Okay, here we go. The spaghetti method works like this.
That wasn't the
Well, it is, but here's the spaghetti about it. Okay, so the spaghetti weaves its way through like this. So here's the positive directions, and you're adding at the turns. Okay, and here's the negative directions. And you're subtracting at the turns, multiplying on the same lines. Okay, so the spaghetti can kind of weave its way through. Does that make sense? It's just a fancy name. It doesn't actually have any real value per se, if you can remember what to do. All right? Now everybody's hungry. Always get a number as a result. Don't forget that. Okay? Can't get a matrix as a result if you're taking the determinant, unless you're then using the determinant on another matrix, which we're going to talk about Tuesday. All right. Are we good? What questions do you have? If any. That's all.
Now we have like 30 minutes left.
Oh,
Yeah.
time.